our second question, or 1.3, we must get determine probability that the arrangement starts and ends with the same letter. So we underline that starts and ends with the same letter. So which means that we still have our 9 arrangements or 9 spaces, 2, 3, 4, 5, 6, 7, 8, 9. So the set must have the same letter here as there. So we're only looking at repeated letters that we have, because it can't. So if we're starting with A, it must end with A, but we only have one A here. So we're only looking at repeated letters, which is 2, which is N, I mean, because we have 2 N. So it can start with N or ends with N. So let's look at it. So starting with N and ends with N. That's the only way it can start and end with the same letter, because we only have N, which is a repeated letter. If there were two, if maybe A was a repeated letter, we would have this as case 1, so starting and ending with N. Then we would have an O, where we're starting and ending with A. Then we add those arrangements, because it's an O. But in this case, it's only N. So once we have N here, we are left with 7 letters. So our arrangements will be 7 factorial. Do we have any repeated letters now, other than if we're starting and ending with N? No. Why? Because N now will be at the beginning and at the end. So out of these remaining 7 letters, which is M, T, H, A, D, E, I, there are no repeated letters there. So once we've used the 2 N's, they are no longer there. So we are now left with, we don't have any repeated letters. So we're not going to have anything in the numerator or in the denominator, or you can just divide by 1 factorial, or by just dividing by 1 or nothing. Now the probability that starts with the same letter is the same as the probability that starts and ends with N. Starts and ends with the same letter. So it would be what we found above, 7 factorial divided by the probability divided by all the possible arrangements, which is arrangements without any conditions, which is always going to be what we find in the first question, which is that 181 over 440. 181, 440. Then the next question should be 1.4. Determine the probability that it will start with A. So again, we have 9 slots, 2, 3, 4, 5, 6, 7, 8, 9, starting with A. Then we can have any other letters here and only have one A. So we have one option to choose from here. So we are left with how many letters now? We are left with 8 letters. So we're left with 8 letters. So what you're going to do, you're going to say the arrangements is going to be 8 factorial divided by in repeated letters. We always check. We only have 2 N's, so it's going to be divided by 2 factorial. But if they said it starts with N, we would then have N in the first position, but then we would be left with 8 letters with only 1 N. So we won't have any repeated letters now, because we've used the first N here. We know it's fixed. We're left with 1 N as part of the remaining 8 letters. So we'll not divide by 2 factorial, because we won't be having 1 N. We're not going to be having any 2 N's now, because 1 is used. Now to the probability. I wrote it in full. The probability that starts with A, it will be 8 factorial over 2 factorial divided by all possible arrangements, which is at 181, 440. To 1.5, they're saying we must find the probability that it will not start and end with the same letter. So again, when it will not start and end with, so the best way or the easiest way to do it is to first find the probability that it's going to start and end with the same letter, and then you subtract that from 1. Why? Because probability that it will start and end with the same letter plus the probability that it will not start and end with the same letter. that is equal to 1. Those two events are complementary because they are exhaustive. They add up to 1. It's either we have starting and ending with the same letter or not. It's just the opposite of each other's probabilities, like being dead or alive. It can't be really in between. So meaning that in this case, when you say doesn't contain that and that, just do it first, say does contain that, which is what we found here, which was that answer here, 7 factorial over that 181 over 440. So we're going to be saying here the probability that it will not end, it will not, so long, start and end with the same letter. It's going to be 1 minus that probability, which 7 factorial and 81 over 440. And we're going to get an answer here. That's how you deal with these questions. We'll look at another word, maybe the second example, and then that should be good enough.